Welcome to this Zephyr Summit. And so we'll start this with this presentation about Devicetree and about configuring Zephyr in general, so mainly focusing on Kconfig and the Devicetree. So let's start by presenting myself. So I'm Roy. I'm a training engineer at Ac6, and I'm specialized in real-time operating systems and Linux. I have a PhD from ENSMA in France, and I have authored a comprehensive Zephyr training course. I also provide training and consulting and support on Zephyr and Linux. So just quick introduction to Ac6, if you have never heard about it. So this company is specialized in embedded system training. So we are specialized in training and support for over 20 years. We have developed an IDE called System. So we have developed many IDEs, but the most popular one is called System Workbench for STM32. It's very popular for debugging and developing applications on STM32 boards. But now it is replaced by Cube IDE. So our training catalog, we have more than 150 courses, like on RTOS, Linux, security, FPGA, architecture of processors, and others. And on Zephyr, we have a training that covers the basics to advanced, like configuring Zephyr and drivers, porting boards, and other things. So what is the purpose of this talk? So basically, we wanted just to simplify adopting Zephyr, because we have noticed that there is a big challenge in adopting Zephyr due to unfamiliarity with Kconfigs and Devicetree. So for some of us, it's something new, and especially if we're coming from bare metal development or traditional real-time operating systems, and even on Linux, if we used to develop on user space applications, this would be something new or just slightly different. So the purpose is to clarify their complexity misconceptions. We're going to showcase that they are very simple and they are very useful. And also we're going to provide a clear understanding how they can help us to enhance the Zephyr development experience, because they have many advantages and they can help us a lot. So firstly, let us just say that on Zephyr we have mainly two configuration frameworks. The first one is Kconfig, and the other one is for Devicetree. So firstly, on the Kconfig, this is for system configuration, so global system configuration, not for specific things. It can help us to enable or disable global features. They can help us to do conditional compilation. And the conditional compilation here, we can do it like the traditional way with macros like #ifdef, or we can do it in CMake, so either to compile this file or not. It can help us also to set some default values, some global default values, also for kernel tuning, some kernel-specific features, and for option visualization. Basically, we have some tools like menuconfig and GUIconfig. They can help us to visualize what are the different options that we have. So basically, if you want to know what I can enable or disable or what is available for my board, here we have an option, we have a tool. We can visualize them. We can search for the option I want, and I can just easily enable or disable them. In addition to this, we have the Devicetree. So we're going more in details about Kconfig in the upcoming slides. And then on the other side, we have the Devicetree. So as its name indicates, it's for devices, for hardware description. So for details about devices, for peripheral configuration, like also memory. So if you have memory mapped addresses, so where are these addresses? So how to configure interrupts, which interrupt line, and so on. It is platform agnostic. So it facilitates firmware portability across different hardware platforms by abstracting hardware-specific details. Basically, everything is abstracted here. So this will easily help us to have portable code and just more global system. So the main purpose is also to make it just in one place, to do all the hardware description, and to make it as portable as possible. And all of this is at build time. By the way, this is, if you're coming from Linux background, this is on the device tree is not at build time on Linux, but in Zephyr it is build time. We'll see how it works. So before going into details, here, let me clarify that there are two roles or two different perspectives. So it depends on which perspective what you want to do with your application. So you can either be an application developer. So basically, you have the port that works on your board. You already have it that works. You're just going to take it, and you're going to customize it for your specific application. So in this case, you just customize your specific application, and this is going to be, most of the time, this is what you're going to do. You're just going to have something already available, and I'm going just to tailor it. So this is the way you want to configure the environment to suit the need of your particular project. And most of the times here, you're going to manipulate two things. You're going to set the values you want into two places. So there are many places, but let me focus on two specific ones, like the project.conf for kconfigs or app.overlay if you have a device tree. Or you can add some extra overlays or fragments in this case, but they are just another way for writing like project.conf or app overlay, just other files. So this is what we're going to do most of the times. On the other side, you're going to be a platform developer. So basically, you're going to port a new driver to your system. You're going to extend Zephyr's capabilities. So Zephyr already have many features, but you're just going to add new additional features to the Zephyr. So usually, we're going to do this at some point, but usually this will come later. And if you're already, you should be already available with using it before actually extending Zephyr capabilities. So this is why we're going to focus today on this part, the application developer, and we're just going to do a quick overview what to expect on the platform developer. So here, basically, you're going to introduce new options. You're going to add the new features, new drivers, new parameters, and you're going to set the values. So basically, here you're going to modify specific files like the default config, which is one default file per board. It could be a default config or a device tree source, and some other files. So a quick overview here. A typical Zephyr application is made of the Zephyr core, so basically the main Zephyr code. In addition to this, we have some modules. So those modules are part of Zephyr. And you sometimes need to add some custom modules. This might be the case. If you have like some custom library, you're going to create a custom library module, and you're going to add it there. And your custom application, your specific application over there. So anyways, in this application, you need to configure it. And when you configure it, you have two options, the Kconfig or Devicetree. So on the Kconfig, the main files that that Zephyr is going to use are the defconfig, the board defconfig, the project.conf, and the fragments. So it's going to merge them all together in order to create the .config. So once we have the .config, this is a special format, not recognized by C code. It's going to use the .config to generate something known by any C application, which is .h or header file. So it's going to create a file called autoconf.h. And this is like a standard C code that you can just a header file that is going to be included and be used without like any other header file. On the other side, for the device tree, there is some DTSIs. So that DTSI are just device tree source include. So basically some include files. They are going to be included by some DTS, so the board DTS. There's only one DTS per board. And in addition, you're going to have the app.overlay. This is one per project. And you might have other overlays altogether going to be merged into one final Zephyr.dts. And the merge here is also automatic. So during the build phase, it's going to merge them together to generate the Zephyr.dts. So if you're going to see the final output, just take a look at the Zephyr.dts in your build directory, and you're going to see the final device tree source. And still the DTS, this is something that is not standard, so not something that we can actually use in C. So after all, this is why it's going to generate a device tree generated.h, which is a .h file that is recognized by Zephyr. by any C source code. So for example, on the Kconfig, so the syntax and the .config would be something like config serial equal yes, or config qart mcux lpurt equal yes equal y. So this one is going to generate something in the .h, but it's going to be used in your code firstly in the CMake. So in the CMake list, you're going to find something like this. So Zephyr library source if def, for example. So here, if this option is set, I'm going to compile this code, this C code. So UART MCX LUPART.c. So this one's going to be compiled only if I enable this option. So this is the conditional compilation in CMake based on config options. And also in your source code, you can just do if def this config option, you're going to compile your code or not. And also, not only for conditional compilation, you can use them to set some values. So the type, it could be like an integer or string or whatever, and you can just directly use them like any other typical macro. So on the other side, on the device tree, you're going to have something like this. So before going into details about the syntax, just some syntax here made of trees and nodes and stuff. So basically, it has some special syntax. And in order to use it in your source code, you have some special macros like dt, instprop, and I want to read a property called current speed. So basically, if I do this, it's going to return the current speed, which is the baud rate of this LPUART. So in brief, it's just some different syntax that's going to generate some defines into .h, and I'm going to include them and use them in my source code. So this is it in simple words. So let's just go deeper into Kconfigs. So the Kconfig, they can be used, in fact, to enable or disable specific features in the application. So conditional compilation, like we have previously seen in the examples. You can define some default values. So by default, I'm going to have this priority or this priority for this interrupt. We can set some boundaries, so like the minimum or maximum values for some features. You can configure protocols, like you want to configure the Wi-Fi, the Bluetooth, or whatever. You can configure them. You can fine-tune the kernel. You change the different kernel schedulers that you have. So we have different possibilities here. So basically, you select which one you want. And you can do some complex conditional configuration. So you can do also many complex things with Kconfigs. It has some limitations. So it should not be used to do something specific for a device. So it should be only kept for global settings. And if you want to do something specific for a specific device, in this case, it would be better to use a device tree because it is designed to be used for this purpose. Even it's possible, so theoretically, it's possible to do everything with the Kconfig, but you shouldn't do this. So the advantages are like flexibility. So basically, you can customize the project in a convenient way. You just enable or disable the functionalities you want. It is so modularity. So basically, you can organize the code by just enabling and disabling the features either you want or you don't want easily. And simplify the configuration management because everything now is centralized into one simple or one way for configuring this option. So you don't have to think in which file I should enable this or where to disable this feature. So everything is just in one place. And over there, you just enable or disable the features you want. So it is a centralized and structured approach to manage the configuration. So the final point, which is very important, is consistency. Basically, it's going to inform a consistent configuration approach across different projects. So why I'm insisting about this point? Because this is not something new that was invented for Zephyr. This is something that exists for years now in many projects. So the Linux kernel, U-boot, or many other projects, even like many open source projects. And if you're not familiar with it, at some point you have to become familiar with it. So, so after all, this is something important that you're going to use it at some point. So let's start by speaking about the initial configuration file. So the application must be configured before being built, of course. So first you configure it, and then you run the compilation. So the final configuration, we said that's going to be in the .config file, that you can find it under build zephyr.config. And everything is based on this .config. So let me highlight something. This .config is generated. So you are not supposed to go and modify it manually. So even though it's possible, it's not supposed to be done that way. So the initial .config is going to be generated at compile time at the beginning. So when you run the compilation of Zephyr, you can look at the beginning at the log. It's saying now I'm going to merge the different files, and I have generated the .config. So what are the different files that's going to merge? The first one is the main one that's called the _devconfig, which is the name of the board _devconfig. So let's take an example here coming from the Freedom MCX board. So Freedom MCX something _devconfig. And so each board has one devconfig, is going to find it, and is going to merge it with other config files. So the other config file is the project.conf. Project.conf, one file per project, is going to merge it. You can keep it empty, by the way, no problem. And you can add some extra fragment. So basically, if you have something special, you can just put it in a different fragment. The typical approach for the fragment, so if you have some options that you want to enable or disable, or you don't want them all the time. So let's say I want to test, let's say, Bluetooth, and I want to test tracing, but I'm not going to use them all the time. Or I want this way for configuring Bluetooth, or this way for configuring tracing. So I will do a fragment for tracing, another fragment for Bluetooth, and I will just add them to the build. In this case, I can just, if I want to enable tracing, I will just add this fragment, and when I want to disable it, I just remove it as a fragment, and voila, I don't have it anymore. So all these files, they have the same syntax. So after all, the same syntax we have seen before, equal yes, or it could be equal the type, it could be integer or string or whatever. So let us focus on the application developer's role. So you as an application developer at the beginning, so you should expect that the board it was already ported to Zephyr. So the vendor usually, or Zephyr, already provided the devconfig that has some options enabled by default. Usually the minimum necessary settings. So usually the vendor will just give you these options, a few of them. So you have the minimum options like mainly GPIOs and maybe some few features enabled, but not many things. So in this case, you as a developer, you should just enable and add the options that you want. So let's say at the beginning, I don't have I2C enabled, so I'm just going to enable I2C. I'm going to enable SPI. At the beginning, it was not, by default, it was not enabled, so this is why I should enable them. So these features, when I enable them, are going to be done inside everything is going to be inside the .config. So the .config can be modified temporarily using the tools, some interactive tools, like the menu config. But the problem is that it's temporary. It is temporary modification. So the modification will be discarded when you delete the build directory. So it is common. You start from a clean environment. You just want to delete the build directory. Deleting the build directory is called pristine build in Zephyr. You can just do it with west build-t pristine. Just delete everything. So in this case, you're going to lose what you have configured. So it's not permanent. So the problem is that because it's not permanent, so you have lost everything you've done. So this is a problem. So to fix this, the best thing to do is just to make this modification persistent. So you do some temporary modification with some tools, and then you see what you have modified, and you just keep it in some special places. So you're going to put them into the project.conf or into a fragment to make it permanent. Or at least it's not going to be removed after the deleting the build directory. And they are portable. You can also share it with some other, with other teams, other people from other teams. So each option has config underscore something. So config GPIO equal yes, for example. So what are the interactive tools? So interactive Kconfig tools, also this is not created for Zephyr. This is something that we also have on many projects like Linux or other many open source projects. And it is recommended at least at the beginning, to set these options using these tools, unless you actually know what is the option or you directly know what you have to set. But when you want to explore or you want to verify what you want to set, it will be better to do it with these tools. So what is this tool or these tools? So basically, it's menu config or Kconfig or GUI config. So these configuration tools are going to read the different Kconfig. So the Kconfig are some special files that we can find them everywhere inside the source code. It's going to read them, inspect them, and when I run this configuration tool, it's going to tell me, yeah, I have these options that you can actually use. So first, it's going to load the .config that it was generated from the dev config. And starting this one, you can now update it. So you can just add or disable features. So like a tool to add and disable the feature. So this has many advantages. So it's going to not allow enabling, disabling the options if there are dependencies to or on it. So the options here, we can have dependencies. So let's say in order to, let's say if in order to use some networking protocol, firstly you have to enable the Ethernet. So you have a dependency to this one. So in order to make it work, first you have to enable dependency, or it's going to automatically force it. So here it depends. So either it's going to let you do this or not letting you do this. So another thing, it could be like, I want to enable Wi-Fi on a board that doesn't have Wi-Fi. So it's going to stop you from doing this. It has a user-friendly interface being used also on other projects. We can have search functionality, something very powerful. You can actually search for what you want, and not only search for it, you can also see the help of each option. So each option has a help description that will tell you what each option will exactly do. So you don't need to actually each time go to the documentation and verify what this option can do. You can also related options. So an option can enable other options or might need other options, or just give you some ideas about other options might be needed. And it will also do a backup. So in case the thing that you have done doesn't suit your project, you always have a backup file that you can get back to the previous options. So it is the .config.old. So the menu config looks like this. On Linux, it's blue, but in Zephyr, it's just different colors. And you cannot use your mouse. So I personally prefer the menu config. I'm just more familiar with it. But there is also the GUI config. It has the main advantage of having the mouse. So you can just click the options. And also another convenient thing that you have the help directly seen in here. So the .config, it looks like this. You have many options that were set and some comments. So hashtag something is just comment. And it will automatically, at the build time, it will generate something called autoconf.h, the header file that's going to be included automatically. So you can save a minimal config. So the minimal config is an option within the configuration tool that can generate a clean and minimal dev config. It will only settings that differ from the default values are included in the dev config. And it can be used as base for new configuration or verification. And it is ideal for creating config fragments. And so the fragments, they were previously called overlay, but yeah, they can be helpful if you want to create your custom fragment. So if you look at the minimal configuration of a full project, you can see like here it's like 10 lines, 10 options that are being enabled. But only this, if you're going to see what's going to generate, it will generate a .config that has 1,167 lines. So the same thing. So this is the minimal one. And if you want to see the actual one, it's going to be much, much larger. Why? Because all the other options are going to get the default values that they already have. Because most of these already have default values. So because the default value is correct, so you can just directly use them. So you can see here we have two options as a minimal. At not minimal, you see that we have many other options that are going to be enabled. So basically, if I enable config tracing equal yes, it will automatically enable something called config tracing thread equal yes, config tracing semaphore equal yes, and so on. All of these options will enable automatically. So how to create a permanent config? So to create a permanent config, you can put it in the project.conf, or you can create an overlay. So creating an overlay, basically you put the options you want to set into a special files, and you either just write them directly if you know what you want to put there, or you just use some configuration tool. I'm just going to give you a method I personally use, very helpful. So basically, when you create this file, you should set the environment variable called extra conf file. We typically do it in the CMake list. So you do set extra conf file, and you put the fragment here, and it will automatically see that you have this fragment and will enable these options for you. So how to make it permanent? So this is how I do it, but there are also other methods. So you can do it with minimal config. So you open the menu or GUI config, and you save you put a backup for the original one. You set the options that you want to set, and then you save the new one with the additional features in another place. So you have the original backup, the original one, and the new one, and you basically do a diff. So you see the difference between those two. I use this command. So you can also do it manually if you want to, or you can use sed. Here, it's up to you to do whatever you want. But this diff, it works very well. It will compare those two and only keep what has changed. You can also do it without the minimal config. Do the same thing. You have the .config. When you enable options, it will automatically create a backup. So you compare the backup with the new one, and you have the options that you have set. But the difference that when you do it without the minimal, you have all the options that have changed with the default values. You can do it that way. It also works very well. So just a quick demo to show you how to do this. It's not in full screen. So it's not in full screen. I'm not sure why. So, this is like this. I did not run it correctly. Yeah, now it's good. So basically here, I'm just going to build, I'm going to open the GUI config. And firstly, I'm going to save a backup. So for the original one, so original.devconfig. So in this example, I'm just going to enable tracing with Tracealyzer. So it's a tracing tool. So I'm going to tracing support, enabling it. And the format is going to be using Tracealyzer. It's a great tool for tracing Zephyr. And here, I'm going to set some specific Tracealyzer options. So I'm going to tell him to start by default at the beginning. And the way for tracing, I'm just going to use a ring buffer. It's going to store everything in a special ring buffer. Anyways, I have done the options that I want to set. I'm going to save the new file with Tracealyzer. So here with Tracealyzer config. So now I have the original one and the new one. I can just simply compare both of these files. You can see here, I'm just going to open them to show you the difference. So this is the original one and the new one with some few additional options. So I can just copy them manually if I want to. Or if there are many options, you can just use diff. And I'm going to put everything in a new file. Let's call it. I'm going to redirect it to enable Tracealyzer. So this is my fragment now. If you look at it, it has these options. And now I just need to put it in the CMake list and tell him this is the fragment that I have. So under here, I will come and just say set extra conf file. This is a new file. Anyways, and when I run it, it should work. So let us continue. Okay, so on the other side, the platform developer's role. So if you are a developer for the internals of Zephyr, in this case, you will need to extend the Zephyr features. In this case, you can add a new custom Kconfig. You might need to define new options. Well, in this case, you need to write a Kconfig. So you need to write some syntax like this. So config, you specify the type, and so on. So this is usually something that for the platform developer role when you want to extend Zephyr. At the beginning, we really recommend that you only go and read them to actually just get some information about the syntax. But anyways, when you use a menu config or GUI config is going to just parse these files and just read them for you and show them for you and just in more, it's just in a different way, stylish way. So on the other side, the device tree. So the device tree, you have a single source for hardware information. Device tree can obtain, in this case, you know everything about the hardware from a single file. That's called the device tree source. When you write a new device, so if you want to add a new device driver, you can just use the device tree just to create them and use them. So it has many advantages. It is for configurability because device tree enables hardware description to be easily configurable. You can easily just modify them, and you do not need to change the C code. So it is common when you want to modify something, typically on bare metal or with some low-level system, you just go and modify the C code to change some peripherals information. Here, you only have the device tree, you modify it, and it should work. And everything we know where it exists. So this is a proven concept, which means that this is not a new concept. It is almost a de facto standardized format. So everybody just now using it. Many projects and the new projects are also adopting it. So a standardized format used by other projects like Linux, U-Boot, and ATF. So the syntax, everything is described as tree. You always have the root / and the node are named. They have some special pattern. So you have the label, the name, and the address. So everything between two square brackets, this is optional. So the node name, this is generic name, so it reflects the function. So for example, here we have timer1 timer something. So you see the node name is going to be timer, not timer1. So the timer1 is the label. And the address is just where it exists. So usually when it is memory mapped, so what is the base address for this peripheral. And each node has properties, and they look like C assignment. And they end up with semicolon. So each property has a type. So it could be an integer. And by the way, here, everything is limited to 32 bits. So if you want to do 64, you have some special syntax to make it 64. You want to double each cell. So let's stick now with 32 bits. It could be a reference to another node. It could be an array of integers. It could be a string, an array of strings. Or it could be like a property like this. So either it's available or not. So either it's enabled or not. So you can just use it like a Boolean. So we have some standard properties like compatible. It could be used to match the device tree node with the actual driver. So the code that's going to handle this. So this is thanks to the compatible. The status, just is it enabled or disabled? And when it's OK, it means that I want to allocate the memory for this device. And reg, which is basically when most of peripherals are memory mapped. So we just want to specify what is the base address and the size of this memory mapped region. This can be controlled with other features as well, like if you see hashtag address cells or hashtag size cell, these are just to control the reg. So let us look at the syntax. So the syntax here is very important. Usually it looks very complex, but let's just simplify it as much as possible. So all starts with the root node, so the /. And then you can have some child node. So the child node is SOC, which is the child of root. So just another node. So we have serial at something. The whole thing is another node. So it is the child of SOC. And the format is the node name at the address. We can have a node label. So the label is user@1. So user@1 is the serial at this address. So the node label, just remember, we can just use it to do a reference to this. To point here, you just use user@1. It's easier to find it. It's just much more convenient to retrieve it. And then you have many properties. So the properties of this node are compatible. So the compatible has a format vendor, comma, whatever the name of the driver that's going to handle it. So here, my UART, for example. The reg, so with the property reg, it has, so this is the base address and the size. By the way, the base address here, it should be the same as the unit address and the name of the node. So the old days it was possible to just do random values. Nowadays being verified, and it should be the same. If not, you're going to have an error. Status, OK. So it means that I'm going to allocate the memory for this one. And the label, so they are used to be, so it was used a lot. Nowadays it was rarely used. The label is called useart1. So just not to be confused with the node label. So this is something different from the node label. So when we talk about the label, we usually reference the node label, not the property called label. And any other custom properties like current speed, for example. So we have initial device tree. So by default, the initial device tree is based on the board.dts that can be merged with other overlay like the app.overlay, and we can extend it like the Kconfig. We can extend it with extra DTC overlay file, so have another overlay that's also going to be merged to this device tree. So the final one is going to be in Zephyr.dts, and they all have the same syntax. So we can include some other files. So device tree can include other ones. So device tree can include .dtsi file. So just like the same thing as DTS. We typically do it to do common configuration, which is the same with a family of boards or SoC. And we usually have, most of them are just disabled in the default configuration, and we just enable them with something specific. So let's say by default, I'm going to configure all the properties with default values, but the status is going to be disabled. And for this board at the beginning, I'm going to enable it. So in this case, in order to know what was the default value, it is easy just to retrieve this DTSI and see what is the value. And if you need to change it or adapt it for my project, you can just get it from there. You can also, it is possible also to include header files, so like in C code. So it is much more convenient. Instead of just putting some 0x address here, it would be just a nicer way just to put a define. In this case, it's just more consistent. And also parameters that influence the behavior, like this is pull up or active high or whatever. So the application developer role, usually we need to customize this device tree, and you do it in the app.overlay, or you might need to add some extra overlays. And everything is based on a structure called struct device pointer, and this is where you're going to do the operations. When it's going to generate the device tree, so everything is based on header file, it's going to become a header file, so it becomes hashtag define, something like this. So the syntax is complex. The purpose is not just actually to understand how to write the syntax. The easiest way to retrieve the syntax is just by using another macro that's going to reconstruct this for you. So basically, instead of writing something like this, it would be easier just to use something like dt node label or dt prop something. In this case, it's going just to reconstruct the define for you. And it's going to retrieve the value here using these different macros. So basically, if I do define useart1 node, is dt node label useart1, so I can retrieve the node. And then on this node, I want to get the property. So dt propt useart1 node, the current speed, so I'm going to get the value of this baud rate. There are also some drivers that have some specific macros as well. So struct device pointer, so all devices should have an instance of type struct device, and this is part of the model. So you can retrieve this pointer by doing device get binding. You put the name, or you can do it with device dt get. Typically, we do it device dt get. So let's see an example. So here we have a node label. So I have a node. So it's called I2C2 node. So in order to get the device, I just do device dt get, and now I can access the device. So now I can do operation of this device. Like first I can check if it's ready. So ready, it was initialized correctly. And then I can just write and read and do the operations I want that way. So just to finalize this, so on the other side, the platform developer role. So basically, if you are going to extend Zephyr, so in this case, You might need to add new drivers or porting it, so you have to respect the driver model. So in this case, you just need to read what is the driver model and understand how it works. And then you can just work on it. There are many other things that you need to develop and work on this and this part. But most of the case, we don't actually need to do this, except you're writing new drivers. So what are bindings? So at the end, so bindings are just some files. They can help us to provide the types of properties used, because you can write anything you want into Devicetree, but they don't have types. So to explain what is the type, you just use binding. And these are YAML files, and they look like this. So model name is just an integer. And it is required, so just giving a type. So this is it. So I hope you enjoyed this simple introduction to Devicetree and Kconfig. And just let me know if you have any question. Yes, sure. Thank you.
Thank you. You know, I work with a few people who are very new to Zephyr, and I'm pretty new to it myself. And something that's tripped me up in everyone so far is the pin control and pin muxing. Is there a solid explanation of how all of that glues together, especially around, I have a device, I want to change from using these pins on the device to these ones, so I want to swap the mux, and I want to change the IRQ. And the next bit adding on to that is, how do you debug the device tree? Because whenever we do this, inevitably you get this sort of big spew of error. Oh, compile error here. It's like, thanks, buddy. So can you kind of give us a bit of background on that, please?
Yeah, yeah. It's always tricky to debug the device tree because it's everything macro and just going to call many things. So there are some. So with time, you're just going to get familiar with the typical errors that so they are usually the same errors that are going to repeat themselves. Basically, you just use a name that doesn't exist, or you did not enable the driver. So what is the best way here? It depends. So you just go with the log. Usually, I think the first log is going to be the first index, and it's going to show you where is the error. So in this case, it's going to give you a hint from where to start. But yeah, with time, you're just going to get familiar. It's going to be the same errors that's going to repeat themselves after all. Yeah, and yeah, and the pin mux. So here you have what I typically do. Firstly, I see the DTSI. So I go up with the DTSI, see similar example. I just do something very similar for this specific board, and I can see where it came from, which header files to know what are the exact values for this board. This is from you should start. And to know really the details, the documentation is very well documented, the Zephyr documentation on this topic. So it is really very helpful. You have all the details you need there. Okay.
Lots of detail, but I did read it a few times. Give me an aneurysm, and I spent a minute at home after reading it all.
Yeah.
It's very, that's the problem. There's all this detail, but no guidance, I guess, is the gap needed.
Yeah. Yeah.
In the interest of time, we will have to take the rest of the conversation outside. I mean, or for later, I think.
Yeah.
Sorry for that. But yeah, thanks, Roy.
Thank you. And thanks. Yeah. So feel free if you have other questions. I will just be here and just have the discussions.